Hi, my name is Stephen Hawes, the founder and CEO of Opulo, and this is the October 2025 Opulo Company Update. Opulo is an open source hardware company making the Lumen P&P, which is a desktop pick and place machine used for automatically assembling electronic components onto circuit boards. The Lumen P&P is meant for assembling PCBs at a wide range of production scales, anywhere from just a handful of boards for a quick prototyping run, all the way up to production of a few thousand units a year, like we do here using the Lumen P&P to make boards that go into the Lumen P&P itself, literally building its own boards. As always, this video goes along with the blog post on our website, so if you're watching this video on YouTube, you can click the link in the description and check out the blog post there. All right, first up, as usual, is our lead times. We are still actively looking for more assembly technicians to join our team to help bring that lead time down. So if you're in the Pittsburgh area and you want to come help us build pick and place machines, please apply. There's a link in the description and the blog post. We are also making some pretty big changes here to facilitate kind of this next tier of production that it's pretty clear we need to start accommodating. It's going to take a little bit, but it is going to remove all of our production bottlenecks, and it is really the only path forward for making sure that we are going to have a same-day lead time. These small incremental changes that we've been making trying to bring it down is just going to be eaten up by increased demand. And we have to make some bigger changes than these small incremental things to actually see an appreciable change in our lead time. That is one of my huge focuses right now, is trying to figure that out. And as always, the official lead time for every product is the same as what is on the product page. That's actually what we use to calculate when we have to ship your order. So if you're ever in doubt about when something's going to ship, check the product page on the website and that will tell you exactly what the lead time is for that particular product. All right, next up is wide feeders, or 2U feeders as we're calling them, because they take up 2 slots on a Lumen P&P. Since the last update, I've actually been able to fully assemble an entire EVT unit. If you're not familiar with the EVT, DVT, PVT structure, we actually have an OM episode talking about it, so you can check it out. We'll put a link in the description. But in general, it's like the first pass of engineering complete, or at least very close to engineering complete, does the thing. The step beyond a functional prototype into it's starting to take a little bit of the form, very roughly. We edit a little bit of how these official terms go, but it's our EVT unit. A lot of things went into getting this EVT unit ready to go and working, mainly porting Photon, which is the firmware that runs on our feeders, over to the new chip with a little bit more flash space. That was a whole thing, but now that's all sorted and working very nicely. A new PCB with a different hole pattern and a couple different features, a couple tweaks and tunes to the PCB layout, circuitry, to make it work with this system. And of course, a lot of CAD tweaks. I talked last time about the peel mechanism being spring-driven. All those tests worked exceptionally well, so I pretty much took all those tests and ported them into the main feeder architecture and getting all that CAD integrated into one unit. And we have an EVT unit. I have it right here. It looks a little play school because it's in colors that film better for video. But this has 16mm tape loaded in it right now. It's some USB-C connectors, and the film peeling mechanism has been working great. I'm really, really happy with its performance. We still have a lot of lifetime testing to do with it, but at the moment, I'm ecstatic about how well it works. It's also so nice to be able to just pull back and then you can freely pull film through. So you only have to drive a little bit of film in with the gears by pressing and holding the button. It'll load a little bit, and then you just disengage the gears and pull the rest of it through, and then you're done. It's great. Saves a lot of time. The firmware works almost perfectly out of the gate. I think there's some tweaks that I want to make to support 2U a little better. It is effectively the same gear ratio for everything, including all the gearing for the whole peel system, so it should be pretty much the same. But at the moment, I'm very, very happy with how well they're performing. There are quite a few things left. The buttons are still exposed. There's no diffusion for the LED. I got to figure out how all that stuff works. There's a lot of printability things that I want to improve where we don't need supports when we're printing a ton of these things. So what we're going to do is make up a few more of these EVT units just for some more testing. We've learned a lot just by building the one, but I want to make a couple more. Then I want to do that last stretch of CAD changes, and then that will be our DVT batch, our design validation testing batch. These are the ones that we're going to use for our public beta. If you're new here, we actually did a beta for our 1U feeders years ago now, 2023, and so we're doing it again for 2U. So if you'd like to join the beta for these feeders, if you already have a Lumen P&P, you use it regularly for useful work, you're constantly pushing boards through, you use 16 or 24mm tape, please sign up for the beta. There's a link in the video description and in the blog post. Just fill out a quick Google form, let us know that you're interested, and we're gonna pick a group of people from that list and send you a bunch of feeders and get feedback on how you like them, and that will inform our PVT run, which is the very last one before we actually go into production. So we're really excited to get going with the beta. This feels good. I've actually been running this on the line as well as we actually run boards here at Opulo to make lumens, and that has been very insightful and has informed a few of the CAD changes that I want to make. So yeah, really, really exciting stuff. Please sign up for the beta if you're interested. All right, next up is our new method of prototyping PCBs. If you didn't catch the last episode, the idea is effectively having a bunch of template PCBs already in stock that have a standardized grid of vias already in them. You buy them from the board shop like this, with the vias in this standardized array. And then when you're prototyping a design in KiCad, you just drop vias where there already are on these template PCBs. Then you can drop it into a UV laser, and then that will cut the top and bottom traces, and you're effectively deciding what these vias are being used for. They're already made, they're already there, you're just choosing what net they're attached to. This means that you can prototype good 2-layer PCBs in about an hour, as opposed to waiting a week or more from the board shop. I'm really excited about this idea. I think this is really gonna be big and important for what prototyping is. I have been spending a lot of time in this back little room where I have the laser, testing settings and experimentation, and we finally have our first working board with this system. This is the board I always do. It's just a microcontroller with a NeoPixel, just to show that firmware spins up, a chip is on it, power regulation works. It's just like kind of almost like the Benchy of PCBs in my mind. And it has traces on the front and back. I selectively chose vias in KiCad that I wanted to use, and then I just lasered around them to isolate them from the ground port. All the other ones don't need to be touched because they're all just connecting to ground. The big first hurdle was getting the settings right, and this took me a while for a number of reasons, and I'm still working on tuning it to be really, really good. I opted to get these blanks made with ENIG plating, which is actually the copper layer, and then they plate it with a layer of nickel, and then they plate that with a layer of gold, a very thin layer of gold. And I chose this because I didn't want to have to worry about oxidation or other layers. I didn't want to have to worry about putting a solder mask on if I didn't want to put one on there, like I didn't with this board. So getting those settings working well was very tricky. What's the density? What's the line resolution for the rastering, for etching these things out? A lot of weird finicky stuff, but I feel really good about where it's at right now. I'm able to pretty consistently cut out board designs that I have. I also tweaked the layout of the blanks. The earlier blanks I had these tight little clusters of vias all together, and that did not give me a lot of wiggle room for alignment. So it was actually pretty hard to get them to all line up bang on. So I just spaced them out a little bit more, and it has not at all impeded my ability to route with the board, but it has made it way easier for getting the laser to make a successful board with its alignment. It can also be a little tricky getting this alignment correct if you're just trying to tweak it in software. So what I decided to do was make it so that when the laser is tracing out the outline, it's framing. In Lightburn, there's a button called frame, and it just kind of lightly traces out the exterior of your part. When it traces onto copper or the gold surface, it does not reflect at all. It's almost invisible. But when it hits the FR4, it lights up really brilliantly. So what I did is I made a tiny little track around the corners where there's a little bit of FR4 exposed. So if you have everything perfectly aligned, it's gonna make that tiny little track in the corners light up really brilliantly. So you can just kind of adjust it and wiggle it until you get there, and then you can tighten it down. I also designed and printed this whole mounting system that you bolt onto the base area of the laser. You can loosen 4 thumb screws and wiggle the board around until you get it right where it needs to be, and then once you see that outline light up really nice, you just tighten down the 4 screws and you're done. You can keep repeatedly putting it back there. The mount also has a pretty consistent mounting system with 3 dowel pins and 2 spring-loaded cams. So when you drop the board in, it's aligned against 2 dowel pins on one side, a 3rd dowel pin on another side, and that pretty cleanly indexes it into one corner, and then you have those cams pushing it against those indexing features. I've been able to remove boards, put them back in, and keep running jobs, and it's still very, very consistent with its alignment. I have not been able to tell a difference. I think this is pretty important to go along with the concept of this board, this standardized array of vias, and using a laser to do this, so I'm really excited about this whole system. It's been working out really well so far. I'm working on taking everything that I've learned about this and putting it together into a GitHub repository so other people can do the same kind of thing. You can download these designs, try them out, tell me what you like or don't like about it. And I'm also going to be working on a video for my channel about this whole process and all the details about what I've been doing here to make this work. I've also been chatting with some people in the Lumen PNP Discord about this idea. Maddie in particular, thank you. So many good ideas we've been exchanging back and forth and trying to get this to work really well. I'm very excited. I'm really excited about this as a concept and as a standard. I'm actually in the middle of cutting a board to replace a jig on our production line. So I'm already trying to use this system for a real thing that we need here at Opulo, which is pretty exciting. All right, next up is job postings. This is a new thing I'm just gonna put at the end of this because we have a lot of job postings open right now. We have 4 job postings up on our careers page. If you're ever curious, you can go check out what we have at any given time at careers.opulo.io. Right now we have a customer service specialist, an assembly technician, a social media manager and video editor, and a mechanical engineer roles all open. So if you want to go check them out, check out careers.opulo.io, link in the description, link in the blog post, and go apply. All right, that's it for this one. Thank you so much for watching our October update. We'll see you again in a month for our November update. Have a great month.